about the factors affecting rate of reaction. Okay, there are 4 key factors that can affect how fast or how slow a reaction can proceed. The number 1 is temperature. Now, how does temperature affect the rate of a reaction? Remember that an increase in temperature of a reaction increases the kinetic energy of that reaction. And if the kinetic energy increases, it means the molecules will collide faster, that is, the frequency of collision increases. And that increase in frequency of collision will increase the possible contacts of those molecules. And remember that molecules, when they collide, an effective collision will lead to the formation of a product. So, increasing the temperature of a reaction increases their frequency of collision and possible effective collision, which can lead to the formation of product, thereby increasing the rate at which that reaction moves. So, increasing the temperature of a reaction increases the rate of a reaction. That is just the end point. Okay? So, the number 2 is concentration of reactant. Now, when the concentration of a reactant is increased, the increase in the possible collision or the possible contact between those molecules, or the possibility of those molecules to undergo effective collision, increases. And if an effective collision is possible, it means that the reaction can proceed as fast as possible. So increasing the concentration of a reactant will favor or increase the rate at which the reaction will proceed. Even from the Newton's principle, you should be able to understand how this increase in concentration works. Okay? Now, number 3 is surface area. Now, what do we mean by surface area? When we say surface area, we mean the area that is reacting. If the surface area or the area reacting is too large, then it means the reaction can proceed as fast as possible. But if the surface area is very small, then it means the reaction will take time. So what it means is that if we are considering this surface area, let's look at something that is in solid form. Something in solid form, let's look at example, your drugs. Your drug. Let's say you have a paracetamol, okay? If you take the solid part of that drug, if you take a tablet of paracetamol, it is going to, like that form, in solid form, it will take time for the paracetamol to dissolve and start reacting fast with your body. But imagine that you have grinded that paracetamol or that drug, grind it and increase. Once you have grinded that drug, you have exposed the drugs. The surface area has been increased. So the reaction will be very fast compared to a drug that is in solid state. So surface area increases as you move from solid to liquid to what? To gas. So an increase in surface area will definitely increase the speed or the rate at which the reaction will proceed. Hence, large surface area increases the rate of reaction, but poor or small surface area will reduce the rate at which the reaction will proceed. The last one is a catalyst. Okay, catalyst. What a catalyst does is simple. A catalyst what? Speeds up the rate of a reaction. It speeds up the rate of a reaction by lowering the what? Activation energy. So the activation energy is like a barrier. It's an energy barrier that prevents a reaction to what? Proceed or react faster. So if this activation energy can be what? Lowered, then it means that the reaction can proceed what? Faster. For example, if you want to kill a fish in water, it will be difficult to kill that fish in water because a fish can move in water. In fact, it survives in water. Water is like a catalyst. But once you bring out that fish from the water, you have lowered the activation energy. That is the supply of that water. So that fish automatically will become weak and you can easily do whatever you want to do with it. So if you want a reaction to proceed faster, you must introduce a catalyst which remains unchanged throughout the reaction process. And instead, it speeds up that reaction and makes the reaction to proceed in the direction that you want. So a catalyst can affect the rate of a reaction by lowering the activation energy of that reaction and allowing the reaction to what? To transit to the activated complex and then form the product. So These four factors are key factors that can affect the rate at which a reaction will proceed. So you should be able to know how to explain them in exams. If they ask you, list and explain the factors affecting the rate of a reaction, you should be able to discuss this one by one using these few points I have mentioned. Okay?